We are going to be looking at a lot of properties today. So I laid them all out for you because that's just a lot of writing. Nobody wants to write that much. So here's the deal with the properties, okay? There are properties of addition and there are properties of multiplication. They're very similar. They're not always the same for each name that goes with them. So if you look, the commutative property, for instance, Brooklyn, I'm up here. The commutative property of addition versus the commutative property of multiplication. Notice what's happening, okay? I always tell people, think of your parents or even your drive to school, okay? You commute to school, we'll say. The commutative property, you commute to school. You are going from home to school, right? Then you go back from school to home. Is the distance different from home to school or school to home? No, it's the same. If you take the same route, it's the same distance, right? So what the commutative property says is it doesn't matter if you go school to home or home to school, they're equal, okay? That's what you see in this picture here. A plus B is the same as B plus A. Remember when we were doing all the more than, less than? When you're adding, I said the more than doesn't have to flip. We flip it because it's good habit for the less than, but you don't have to flip it because if you do 1 plus 2 or 2 plus 1, you get the same thing, okay? So that's commutative property of addition. An example would be if I do, need a pen here, 2 plus 7 is going to equal 7 plus 2, okay? You can flip the order and they are still equal. The same is true of multiplication. I can multiply A times B or B times A, and they will be equal expressions. So like if I said 3 times 9, what's 3 times 9? 27, okay? Is 9 times 3 also 27? Yes, okay? So when you multiply, you can switch them. When you add, you can switch them. Can you switch them when you subtract? No, right? They'll be different. Can you switch them when you divide? No, they will be different, okay? So the only time commutative property works is with addition or multiplication. So when you write these out, like when I ask you which property is this, you're going to write commutative property. I don't care if you don't write property. You can say commutative of, and then either put a plus sign for addition or a times sign for multiplication. Or if you'd rather write the word out, write the word out. Okay? Okay, then it's the associative property. Associative property is all about parentheses, okay? If your information inside your parentheses changes, not switches places, if it changes what is inside parentheses, that's the associative property. So, for instance, if I say A plus B and then I add my C, versus if I add my B plus C and then add my A after that, that's the associative property. So it's like saying 2 plus 4 plus 6 is the same as 2 plus 4 plus 6. Okay, it's just moving the parentheses to a different place. The same is true for multiplication. I can do 2 times 3 times 4, or I can do 2 times 3 times 4. Okay, you'll get the same answer every time if you just move the parentheses all with multiplication. Okay? And then these last few, the identity, right? These are the same, identity, identity. The identity property of addition, I always tell people, think of who you are. We don't want who we are to change because we added something to whatever we did. I always want to be true to who I am, right? So if I add nothing to me, I'm going to get me back, right? Well, that's the identity property of addition. A plus 0 is still going to be A. Or 7 plus 0 is still going to be 7. Okay? So that's identity of addition. Now, here's where the identity property of multiplication is a little bit different, because if you multiply something by 0, what do you get? 0. You don't get that same thing back, right? So the identity property of multiplication is, what do you have to multiply by to get that same thing back? 7 times 1 would get me 7, right? So this one is, I'm going to do 8 just so we're using a different number. 8 times 1 equals 8 is the identity property of multiplication. If I multiply something by 1, I will get that same thing back. Okay? And then last two, the 0 property of multiplication says if you multiply anything by 0, it will be 0. So if I do 9 times 0, I'm going to get 0. If I do 1,000,000 times 0, I'm going to get 0. Okay? And then the last one, multiplication property of -1. If you multiply a number by -1, it becomes the opposite of that number. So if I do -1 times 6, my answer now is a -6. That also works with a negative number. If I do -1 times -4, my answer is the opposite, which would be a +4. Okay, so if you multiply something by -1, you get the opposite of what you had. Those are the properties. Not terribly exhilarating, I know, but we're done with them now. Now we're just going to figure out which one we're using when. Any questions on how those properties work? Okay, then here's what we're going to do. I want to know, I'll try and leave as many of these in the picture as I can for you. What property is being illustrated here? So look at A. 42 times 0 equals 0. Which property is that? That is the 0 property of multiplication. Okay, so you may just write 0 prop of, and then multiplication can just be the multiplication symbol. You don't have to put the whole word in if you don't want. All right, what about B? 7 plus 13 in parentheses plus 5, Z, not 7. Z plus 13 plus 5 equals Z plus parentheses 13 plus 5. Brooklyn, not during the lesson. Wait till after the lesson. What is that? That's associative of addition or multiplication? Addition. Okay, so this is associative property. And again, I'm not a huge stickler on property. If you say associative of addition, that's great. Okay. What is it when you add 0 to something and get that same thing back? 3A wants to stay 3A. What property is that? Identity of addition. So this is identity of addition. And then last one, 6x times 1 equals 6x. All right. That's identity of multiplication, okay? Any questions on that? So some of it's naming properties. I would keep this list right next to you while you're doing the homework so that you can take a look at all the properties. You will have to be able to name properties for me on the quiz, so make sure you get these in your brain in the next few days here. All right, so here's an example of when you would use these properties. And guys, this is something that you should use all the time. It is going to make your life so much simpler if you do, okay? Here's what it says. A movie ticket costs $7.75. A drink costs $2.40. Popcorn costs $1.25. What's the total cost for all of it? Well, if you're just standing there trying to figure it out and you go, okay, $7.75 plus $2.40. Carry the one. Okay, now we got to add. Your brain gets just a jumbled mess of numbers, right? But let's lay this out. $7.75 plus $2.40 plus $1.25. Okay? There is an easier way to add this right now. Do you see it? What? Right. So you have a 775 and a 125. If we rearrange so that it's 775 plus 125 plus 240, it's a whole lot easier to do mental math when they work out to nice whole numbers like that, nice rounded numbers, not throwing things around. Yeah, so we would have been doing this first. Now we're doing this first, okay? That is the commutative property because we just switched the order of these first two, right? Of the last two, sorry. So if we just switched their order, we did the commutative property. And I don't know about you, maybe you're not at a place in your life yet where you do this, but I do this all the time at the grocery store, when I'm shopping for clothes, when who knows what it is. When I'm adding up dollar amounts, I always rearrange them because it's such an easier problem, okay? So that's you using the commutative property if you do that. It's beautiful. What is 775 plus 125? So you have $7, $8, $9, right? A quarter and 3/4 is $1. So that's $9 plus 240. And now look how much easier it is to add 240 to that than it is to add to 775, okay? So you add that together, all total, it would cost you $11.40. Okay, impress your parents the next time you're out somewhere when they're like, what is this and this and this? All like, how much is this going to cost us? Just flip it around in your head, do a little mental math. They'll be like, ooh, wow, look at you go. Tell them, I know the commutative property. It's a beautiful thing. All right. Next thing. Any questions so far? We doing okay? Okay. These ones, it says simplify the expression. Now here you're going to use some properties too. Right now they're saying you're going to do 5 times 3 times n. You're going to multiply the 3n first and then the 5. Well, that doesn't make a lot of sense to simplify this because we don't know what n is. So instead, we're going to do it 5 times 3 times n. Which property is that? That now I'm going to multiply the 5 times 3 instead of the 3 times n first. The parentheses moved to something new. That's associative, right? That's the associative property of multiplication. So this simplifies to 15n because of the associative property of multiplication. Okay. Can anyone tell me what you would do with b to make it a simpler problem? What would you do first? You can't add 4 plus 7 because they're not like terms, right? One has a b attached to it and the other one doesn't, so you can't combine those. Which ones can you combine right now, though? The 4 and the 8. So you're going to go 4 plus 8 plus 7b. Now look at which property that is. It was 7b plus 8. Now it's 8 plus 7b. To school, back home, home to school, same distance. What was that? That's commutative, right? That's the commutative property. So then from there, you're going to do 4 plus 8 is 12 plus 7b. Can I add 12 and 7b? Is that 19b? Don't do it, okay? Everybody wants to do it, and some of you are going to do it. Avoid it, okay? You cannot add them if one has a variable and the other doesn't, or if they have different variables, okay? So 12 plus 7b, the reason we could do that is the commutative property of addition. Okay, last one here. We are doing 6 times x times y. Essentially, this is 1 times y. Okay, what we're going to do, excuse me, is we're going to turn this y over y. What is y divided by y? What's 12 divided by 12? 1. So what's y divided by y? 1, right? Any number divided by itself is 1. So we're doing 6 times x. This 1 on the bottom doesn't change anything. This becomes a 1. So 6 times x times 1, or 6x times 1, is going to equal 6x, which property says that when you multiply something by 1, it's the same thing. What didn't change? Your identity, right? So this is identity of multiplication. So here's the thing, guys. You may never have known that you knew all these properties, but you've probably been doing these properties for a long time. This is the why behind why the math works. This is the why, okay? So hopefully you can appreciate that a little bit, that it makes sense now why you're able to do some of these things. Okay, last thing, counterexample. If I ask you to give me a counterexample for something, I'm saying something's false, like this thing is not true, and here's why. The counterexample is what shows me that something is false. And you only need one counterexample to know that something is false. So we're going to look at these, see if it's a true or false statement, and if it's false, give a counterexample. So give a situation where it doesn't hold true, okay? So this first one, for real numbers a and b, a times b will equal a plus b. Is that true or false? False. That is false. Most definitely false. Can you give me a counterexample? Can you give me a situation where it is not true? Can you plug in numbers that would not make it true, in other words? Izzy? There you go. So 1 being a, oops. If 2 is b, then this would have to be 1 plus 2. So 2 does not equal 3. So this is a counterexample. Okay, that setup is a counterexample. This is why it's false. Okay. How about this one? For real numbers a, b, and c, is a plus b plus c equal to b plus a plus c? That is true. So you don't need to find a counterexample. There won't be one. There's no set of numbers that you could plug in here that will make this false. Okay. Basically what they did was they did the commutative property followed by the associative property, and it became that. Okay, so that is true. Any questions? All right, that's your lesson.